Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about multiplying and dividing radicals and rational exponents. So in order to multiply or divide radicals, you need to have the same index. And the properties of exponents apply to rational exponents as well. So, perform the following operations. I have the square root of 8 times the square root of 10. All right, well, I can put those together. So 8 times 10 would be the square root of 80. And then I can break them apart to simplify. So the square root of 80, I could break that into 16 and 5. And I'm always trying to look, when you're breaking up, you're trying to find numbers that are perfect squares or perfect cubes if you're dealing with cube roots. So 16 is a perfect square, and 16 times 5 makes 80. So then if I take the square root of 16, I get 4. So I have 4 square roots of 5. Okay, perform the following operations. So I have the square root of 3 times the cube root of 3. So these are not the same index. So I cannot perform this operation in radical form. Okay, so we can't multiply radicals since their roots are not the same. Okay, if I had 2 to the 1/2 times 2 to the 1/3, I guess I probably should have made those 3's, but then I can go ahead and do this. Okay, so what I would do is I would, when you're multiplying, you add the exponent. So I'd have 2 if they have the same base. I have 2 to the 1/2 plus 1/3. All right, so I need a common denominator so that I can combine them. So I'm going to make the common denominator 6. All right, to go from 2 to 6, I multiply by 3, so I have 3 6. And to go from 3 to 6, I multiply by 2, so I have 2 6. And then 3 6 plus 2 6 would give me 5 6. So it's 2 to the 5 6. And if I wanted, I could even put it back now in radical form. All right, perform the following operation. I have the square root of 8 over the square root of 2. All right, so I can do 8 divided by 2, all in the radical. 8 divided by 2 gives me 4. Well, the square root of 4 is 2. All right, this one, the square root of 10 over the square root of 8. Okay, again, I could do the square root of 10 over 8. Okay, that one doesn't just come out to be an integer, but I can simplify the fraction. So I'd get 5/4, and then I could break it apart, the square root of 5 over the square root of 4. So there's nothing I can do with square root of 5, but square root of 4 is a perfect square. So I get the square root of 5 over 2. All right, perform the following operations. So I have 2 root 3 plus 3 root 7 times 2 root 3 minus 3 root 7. So this is something later you're going to learn how to do this a lot quicker because this is actually a difference of squares. Okay, but we're going to multiply, and this is going to be one of those double distribution problems. So I'm going to kind of draw a model. So I have 2 square root of 3 and positive 3 square root of 7, and I have 2 square root of 3 and negative 3 square root of 7. And I'm going to multiply each box, so the top with the side, I'm going to come together. So 2 square root of 3 times 2 square root of 3 would give me, well, 2 times 2 would be 4, and the square root of 3 times the square root of 3 would be the square root of 9, which then becomes 3. So when you square a square root, it actually just gets rid of those. It's just 3. So 4 times 3 is 12. All right, 2 square root of 3 times 3 square root of 7. Well, 2 times 3 would give me 6, and then 7 times 3 would give me 21. And then in the other one, I'm going to have 2 square root of 3 times negative 3 square root of 7. So it's going to be the same, except for it's going to be negative 6 square root of 21. And then I have negative 3 root 7 times positive 3 root 7. Well, negative 3 times positive 3 is going to give me negative 9. And then the square root of 20, or the square root of 7 times the square root of 7 is going to give me the square root of 49, or just the square root of 49 is 7. So I have negative 9 times 7, which gives me negative 63. And then when I combine the like terms, I have the 6 square root of 21 and negative 6 square root of 21. Well, they kind of cancel each other out. So one's positive, one's negative, and they are matching. So now I'm left with 12 minus 63, which gives me negative 51. All right, this one. I have 14 times 3 to the 1/2 over 16 to the 1/4. So I really have 14 times the square root of 3 over the 4th root of 16. Okay, well, 3 is not a perfect square, and 16 is a perfect 4th root. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 4 times gives me 16. So I'm going to change the 4th root of 16 to just be 2. And I have 14 square root of 3 over 2. Well, 14 over 2 I can simplify to be 7. So 7 square roots of 3. Find the value of k if k to the 1/2 times 27 to the 1/3 equals 2 times the square root of 12 times the square root of 36 over 2 square roots of 3. So I'm going to focus on the right side of this, and I'm going to try to simplify it as much as I can and figure out what matches with it. So I have 2 times the square root of 12. I'm going to break that up into the square root of 4 times the square root of 3. And the square root of 36, I'm going to break that up into just 6 because it's a perfect square. And I could make the square root of 4 a 2 at this time, or I could just leave the bottom. So the 2 in the numerator and the 2 in the denominator are going to cancel. The square root of 4 is going to become a 2. The square root of 3 in the numerator and the square root of 3 in the denominator are going to cancel. So I'm going to be left with 2 times 6, which is going to give me 12. So I need the left side to equal 12. So I know I'm going to take the square root of something and then the cube root of 27. Well, the cube root of 27 is 3. So I have the square root of k times 3. Well, I know that 4 times 3 will make 12. So I need this to equal 4, okay? And the square root that would give me 4 would be 16. So k must be 16. All right, find the area of the figure below. So if I'm finding the area of a rectangle, it's base times height. So I'm going to have to multiply these. I'm going to simplify them a little bit first. So the square root of 75, I could break up into the square root of 25 and the square root of 3. Well, the square root of 25 is 5, so it's 5 root 3. Okay, and then I have 11 square root of 3 minus 2 square root of 8. Well, I can break up the square root of 8 into the square root of 4 times the square root of 2. The square root of 4 is 2. So 2 times the square root of 2. So I have 4 square root of 2. So now I have 5 square root of 3 times 11 square root of 3 minus 4 square root of 2. And I'm going to distribute. And when I do 5 times 11, I get 55. And when I do the square root of 3 times the square root of 3, I get 3. So that's going to give me 5 times 3, which is going to give me. And then on the next one, I'm going to do 5 times 4, which is 20, times the square root of 3 times the square root of 2. Going to give me the square root of 6. All right, so 55 times 3 is 165, minus 20 square root of 6.